Hi everybody. Matrices. Matrices chapter. Guys, here in this chapter, there is nothing where you need to apply your brain power because totally full of formulas and some relations you need to remember. Some names and formulas and methods to do that only you need to remember. Very easy chapter, non-mass. You will also can do, but only you need to remember some formulas. What is a matrix, guys? Arrangement of some numbers or maybe alphabets in the form of rows and columns. Horizontal, called rows, and verticals are called columns. A matrix may be denoted this way or this way. There is one more way, but no, this is for your standard only these two ways, guys. Now, two matrices can be added or subtracted. Now, wait. All of first, suppose if I write 1, 2, 3, 4, 5, 6. How many rows are there? 1, 2, 3. Because 1, 2, 3. Three rows are there. So three rows. And columns, how many? Columns means this vertical. How many? Two columns are there only. So 3 by 2. We write like this and we say this as 3 by 2 matrix. Obviously, rectangular matrix. It resembles the shape of a rectangle. So we write like this and say 3 by 2 matrix. So the first one indicates the number of rows and the second one indicates number of columns. So if a matrix is denoted this way, it is written M by N matrix. That is the order of the matrix. Then the number of rows here M, number of columns, you know that. Several types of matrices, guys: rectangular matrix, row matrix, diagonal matrix, column matrix, upper triangular, lower triangular, null matrix, identity matrix, unit matrix. All those things already you have seen in class video. I will cover here the main points. Two matrices can be added or subtracted only if they are of same order. If order is not same, then you cannot add. How to add? Suppose 2, 3, 5, 7. And you are to add this with a matrix -5, 3, 2, suppose -6. Then what is the result? Matrix and element will be added to the element of its same position. Like this 2 will be added with -5. So 2 plus -5. 2 plus -5, that is -2. 3 plus 3, that is 6. 5 plus 2, that is 7. This 5 plus this 2, 7. Now, this 7 plus -6. 7 minus 6, 1. So, this is the result of these two matrices. Similarly, it can be subtracted also. So, for addition and subtraction, the two matrices which you are adding or subtracting, they must be of same order. Otherwise, addition and subtraction not possible. Okay. Now, multiplication of matrix. If you multiply a matrix by any number, any scalar number, then what will happen? Each and every element of the matrix will be multiplied by that number. For example, suppose A is a matrix and the elements are 2, 3, 4, 5, 6, 7. And I need to get 5A. 5A means what? 5 multiplied by this matrix A. That is 2, 3, 4, 5, 6, 7. So if I want to take this 5 inside, that means I want to multiply this matrix by 5. What will happen? Each and every element of the matrix will be multiplied by that number. So it will be 5 to the 10, 5 to the 15, 5 for the 20, 5 to the 25, 5 6 the 30, 5 7 the 35, and that's all. So this is, guys, multiplication of a matrix by any scalar number or any number. Now the main important thing is multiplication of two matrices. Multiplication of two matrices. Guys, this is important because there is a condition that two matrices can be multiplied only if the number of columns in the first matrix should be equal to the number of rows in the second matrix. For example, if you want to multiply these two matrices, suppose the order of the first matrix is m by n, then the second matrix with which you are multiplying, it will have to be n by anything but n by. Why? Because number of columns in the first matrix is n, and that should be equal to the number of rows in the second matrix. See, number of rows in the second matrix, so n, sorry. So now you can multiply. Now suppose the second matrix is of the order n by k, then if you multiply these two matrices, then the result will be a matrix of the order. Of which order? How to remember? Where I have ticked, forget that. If you forget that, what you are seeing, what is remaining from the first? M. What is remaining from the second? K. So the result will be M by K. Finally, if you multiply a matrix of the order M by N with another matrix, that is the second matrix of the order N by K, then the resultant or the result of resulted matrix will be what order? M by K. Because the number of columns of the first matrix should be equal to the number of rows in the second matrix. So sometimes may be possible, suppose if I name this matrix as A and you have multiplied the second matrix I am naming as B. So there is a result is what? A into B. In algebra, A into B you do or B into A you do, both are same. But in matrix in general, they are not equal. So in general, means exceptional case I'm not talking about. In general, AB is not equal to BA. Sometimes it is also possible that AB is possible, but BA is not possible. Means AB will exist, BA will not exist. Why? Because that condition. Which condition? Number of columns in the first matrix must be equal to the number of rows in the second matrix. For example, see, suppose if I take A to be a matrix, suppose a row matrix 1 2 3 4, and B is a column matrix, again 1 2 3 4. I think same example I took in class video also. Okay guys, no problem. Now what will happen if we want to check whether A into B is possible or not? A into B is possible or not? What is A, guys? 1 2 3 4. How many rows? Only one. How many columns? 4. And we are multiplying with which matrix? B. Well, how much is B? 1 2 3 4. Oh wait guys, yeah, 1 2 3 4. And here 4 rows are there, 1 2 3 4, but only one column, it is 4 by 1. All of first I will check number of columns in the first matrix, 4. Number of rows in the second matrix, 4. Yes, product is possible. And what will be the result? 1 by 1. 1 by 1 means 1 row and 1 column. 1 row and 1 column means only one element. So guys, your result will be, and how the multiplication will be done, guys? Multiplication will be row by column. Row by column. Row of the first will be multiplied with the column of the second. So here only one row will be multiplied by the only one column of the second. So result will be what? 1 into 1. This one into this one. 1 into 1 plus, now the next. 2 into 2 plus 2 into 2 plus the next. 3 into 3. 3 into 3 plus the next 4 into 4. And now finally if you do 1 plus 4, how much? 1 plus 4, 5, 3 3 are 9, 4 4 are 16. 16, 9, 25, 4, 29, 1, 30. So guys, only one element. Now suppose you want to check whether BA is possible. Check B. B is our column matrix. That is 1, 2, 3, 4. Multiplied by A. A is the row matrix 1, 2, 3, 4. Check whether the product is possible. This is 4 row, 1 column. And here 1 row and 4 columns. Number of columns in the first is equal to the number of rows in the second. Yes, the product is possible. But then The result will be what? 4 by 4. 4 by 4 means what? 4 rows and 4 columns. Guys, 4 rows and 4 columns means what? 16 elements. 4 rows, 4 columns. So 16 elements. How the multiplication will be done? Row by column. Row by column. Row of the first will be multiplied with the column of the second. So in first row, how many elements? Only one. In first column of the second, how many elements? Only one. So 1 into 1. 1 into 1. Now, first row will be multiplied with the second column. In second column, how many elements? Only 1, 2. So 1 into 2. Now, first row into third column. Third column, how many elements? Only 1. 1 into 3. Or 1 into 4. Then we will take the second element. That is what? 2. So 2 into 1, 2 into 2, 2 into 3, 2 into 4. Then the third element. 3 into 1, 3 into 2, 3 into 3, 3 into 4. And then the fourth row. 4 into 1, 4 into 2, 4 into 3, 4 into 4. Finally it's 1, 2, 3, 4, 2, 2 2 ja 4, 2 3 ja 6, 2 4 ja 8, 3 1 ja 3, 3 2 ja 6, 3 3 ja 9, 3 4 ja 12, 4 1 ja 4, 4 2 ja 8, 4 3 ja 12, 4 4 ja 16. This is the matrix 4 by 4, which is BA. So guys, you can see here, AB is totally different and BA is totally different. Luckily, both are possible here. Not necessarily both will be possible all the times. Okay, guys. So just one example I have taken, such that multiplication should have come to your mind again, because this multiplication is the main thing in this chapter. One more example, if you want to see, look here. Suppose I will take A to be a matrix 1, 2, 3, 2, 4, 5. And B is equal to, suppose, guys, here see, this is 2 rows and 3 columns. So second matrix, if I want AB to be possible, it will have to be 3 by. Then only it's possible. So 3 by means 3 rows. So I am writing this way. Suppose 3 5, 1 2 and 2 5. So now this is what? 3 rows and 2 columns. So AB possible? Obviously possible, because AB means, here order is important, guys. First A means first you have to place A. So wait, 1 2 3, 2 4 5 multiplied by B. B is how much? 3 5, 1 2, 2 5. So number of columns 3, number of rows 3. That means the result must be 2 by 2. 2 by 2 means only 4 elements will be there. Only 4 elements will be there. 2 by 2. Already we know the result. How the multiplication will be done? Row by column. Row of first will be multiplied by the column of the second. So what we will do? First row of the first matrix will be multiplied with the first column of the second matrix, one by one. See, first row means 1 2 3, and first column of the second matrix means 3 1 2. So 1 into 3 plus 2 into 1 plus 3 into 2. And again, first row with the second column. First row of the first with the second column of the second. So 1 into 5 plus 2 into 2 plus 3 into 5. The multiplication of first row of the first matrix, first by first column of the second matrix and then by second column of the second matrix. Now we will take the second row and do the same thing. That means second row will be multiplied with the first column of the second. So 2 into 3 plus 4 into 1 plus 5 into 2. And now the second row will be multiplied with the second column. So 2 into 5 plus 4 into 2 plus 5 into 5. That is equal to 3 plus 2 plus 6. This is 5 plus 4 plus 15. This is 2 3 are 6, 4, 10. This is 2 5 are 10, 4 2 are 8, 5 5 are 25. So finally, this is equal to, guys, 3, 2, 5, 6, 11. This is 5, 4, 9, 15, 24. This is 6, 4, 10, 6. 6, 4, 10, 10, 20. And this is 10, 8, 18. 18, 5, 23 plus 20, 43. This is the result. So, yeah. So the multiplication you have seen, guys, with a scalar number also, and multiplication of two matrices also. That is the main and most important thing part of this chapter. Now remaining small things are there, guys. Transpose of a matrix. Transpose means what? Transpose of a matrix means you will transfer rows into columns or columns into rows. For example, if A is a matrix, suppose 2, 3, 4, 5, 6, 7, 8, 9, 10. This is the matrix A. So transpose can be denoted by A T, or sometimes your book may denote by A dash. T, that at the top I have written. They may write a small, they may write capital. I am writing capital. So A transpose will be how to do? Either you write rows into columns or columns into rows. I am writing rows into columns. First row 2, 3, 4. I am writing in first column. Second row 5, 6, 7. I am writing in column 5, 6, 7. Third row I am writing in third column 8, 9, 10. 8, 9, 10. So this way transpose is done. Now you guys, symmetric matrix and skew symmetric matrix definition, if you know, if A is equal to 80, that is called symmetric matrix. And if a matrix is, wait, A is equal to minus 80, then it is called skew symmetric. These definitions you know already, you have done in class video, not going to discuss in detail. uh, Properties also, what, transpose of A transpose is equal to A plus B whole transpose is equal to A plus B transpose of whole is equal to A transpose plus B transpose. Guys, all these properties already you have done. Maybe written in your book also. Wait, I will show you from your book. Wait. Symmetric matrix, skew symmetric matrix. And then I have taught you about orthogonal matrix also. Yeah, 15. Look at this. Addition, subtraction, that multiplication of two matrices, C transpose. Properties, we see, guys. A matrix is transpose of its matrix, that is A is equal to A dash. A dash, that dash of dash means transpose of transpose. Second is what? Okay. Second is what, guys? A plus B. The transpose of whole this A plus B is equal to A transpose plus B transpose. Guys, they have not written for minus, but for minus also it is valid. That means A minus B whole transpose is equal to A transpose minus B transpose. Now, the transpose of the two matrices are equal to the product of their transposes in reverse order. Yes. This thing you have to remember, guys. Product of two matrices, you are multiplying two matrices, and then you do the transpose of that product. Then that will be equal to the product of their transposes, but in a reverse order. Means it will not be equal to A dash into B dash. It will be equal to B dash into A dash. That is B transpose into A transpose. So this important thing you need to remember, guys. Now symmetric matrix, see, the definition is written here, guys. Symmetric matrix when A is equal to A transpose. Skew symmetric when A will be equal to minus of A transpose, or you say A transpose is equal to minus A. A square, guys, here in algebra, if square of a matrix, that is A square, means you cannot do the squaring of the elements. If question will ask you A square, that means you'll have to get it by A into A. So wait, suppose if a matrix is 1, 2, 3, 4, and they are asking A square, then you will have to get it by writing A into A, multiply the matrix A with itself, 1, 2, 3, 4, that is A into A. And now according to that multiplication rule, you have to multiply the product you will get. Obviously 2 by 2, 2 by 2, so the result will be 2 by 2. So that will be A square. So that way you'll have to obtain A square. You can see the multiplication is shown here. And if A cube, then again that A square you have to multiply with A. Guys, this I means identity matrix. You may call unit matrix. This main see this main diagonal will be 1, 1, 1, and remaining elements will be 0. Now see, this A is given. Such a big question they cannot ask you for 1 mark. If they want to ask this type of question, then the matrix given should be 2 by 2. 3 by 3 means it will not be 1 mark question, guys. See, though this is a big question, not a 1 mark question, but for your practice you can do. First you have to obtain A cube. How? A into A square, then that A square into A cube, and then you have got A cube also, A square also, minus A also. Here this I means 3 by 3 order identity matrix. Why sir 3 by 3? Because your matrix is of 3 by 3. So this I will have to be 3 by 3. See. First they have obtained A cube. First A square is obtained, then A cube is obtained by A square into A. And now calculating this, A cube already obtained, plus 2 into A square, this minus A, and minus 20 into this I, that is 3 by 3. And finally it is coming to 0, 0, 0, 0, 0 means null matrix. Okay, all these examples, guys, you will have to see. Even if you don't do, no problem, but just have a look. It will be better for your revision work. These are the multiplication. Easy question, guys. Determinant. Determinant means it will be a number. Wait, I'll come to this determinant later. Minus cofactors, properties of determinant. Okay, fine. Let's see. Determinant of a matrix means it will be a value. It will be a value. Yeah. See. Wait, guys. Determinant. Determinant means suppose a matrix is given, guys, then that determinant of A, it may be shortly denoted as det A, or sometimes it may be denoted as absolute A, or sometimes it may be denoted by delta or delta. Yeah. So we will write it det A or this absolute A. Now, how to calculate? For suppose a matrix is of this of the order 2, suppose 2, 3, 4, 5, then your det A will be equal to left into left minus right into right. That means here 2 into 5 first, then minus sign, and then this right multiplication, that is 3 into 4. What is the number? 2 5 are 10 minus 4 3 are 12 is equal to minus 2. This is the value of the det A. So very easy. It is looking like 1 mark, no, because it is 2 by 2. But if it will be 3 by 3, then it will not come so easy. See, suppose this is given as 1, 2, 3, 4, 5, 6, 7, 8, 9. You are going to calculate the determinant. So guys, determinant of this may be positive because it will be a number. It may be positive, it may be negative, it may be 0 also. If the determinant of a matrix is 0, then that matrix is called singular matrix. If it is not equal to 0, then that is called non-singular matrix. For example, if I calculate here, the rule is, I'm not going to guys rule, because the rule I have discussed in class video. Lot of sum of the products of the elements of any one row or any column with their cofactors that I have taught to you there. Forget that, guys, because ultimately what I taught to you, that you do with the first row only. Why convenient to do? So first row we will take, and the sign plus, minus, plus, because that cofactor allotment sign rule already plus, minus, plus, minus, plus, minus, plus, minus, plus. This is for 3 by 3, but for 2 by 2 it will be what? Plus, minus, minus, plus. Here from only this 2 by 2. For the 2 by 2 it will be this. So how to do? This first element 1 multiplied by, now what you will do? Deleting the row and the column in which this one element is lying. So what is remaining? 5, 6, 8, 9. 5, 6, 8, 9. Now minus second element, this 2, multiplied by what? Deleting the row and the column in which this element 2 is lying. So if you delete that row and the column, the remaining is 4, 6, 7, 9. 4, 6, 7, 9. And plus third element 3. Wait guys. 3. And then deleting the row and the column, it will be 4, 5, 7, 8. 4, 5, 7, 8. So that is equal to 1 into, again left, then right. 5 9 ja, 5 into 9 minus 6 into 8, minus 2 into 4 into 9 minus 6 into 7, plus 3 into 4 into 8 minus 5 into 7. So guys, that is equal to 45 minus 48. This is minus 2 into 36 minus 42. This is plus into 4 8 ja, 32 minus 35. So 45 minus 48 minus 3. This is 36 minus 42. How much? Minus 6. Minus 6 into minus 2. Minus 6 into minus 2 plus 12. And this is 32 minus 35. That is minus 3. Minus 3 into plus 3 minus 9. So guys, ultimately it came 0. Means what do you know? The matrix A is called a singular matrix. Why, sir? Because it's delta A, I write, or data I will write, data. Det A or absolute A, because data is equal to 0. And if data is not equal to 0, it is called singular matrix. If delta A is not equal to 0, then A is called what? Non-singular matrix. Non-singular matrix. All these things you have seen, guys. It may be any positive number, it may be any negative number as well. So actually for 1 mark, which is relevant, 2 by 2, not 3 by 3. 3 by 3 matrix will be involved, means the question will go beyond 1 mark. So the chances are very high. How much high? 90% chance that the question they will ask you, if any calculation based question will be involved for 1 mark, it should be 2 by 2. Otherwise, question will not be a 1. So, okay guys. Now, minors and cofactors. Already we have discussed, guys. You know what is a minor, what is a cofactor. Along with the minor, if you associate the sign, and what is that sign rule, already I have written here. From where these are coming, that also we have discussed in class video. And what is minor? To find out the minor of any element, delete the row and the column in which that element is lying, and write down the remaining things. That is the minor. Along with that minor, you will associate the appropriate sign, plus or minus, that will be called cofactor. So I'm not going to discuss that. Already you know that. Here it should have been given. Wait. where we did this determinant, inverse of a matrix. Determinant. Yes, see, a determinant. See, guys, determinant of a matrix or a matrix is a number which is associated with the square matrix. The number may be positive, negative, or zero. Determinant of a square matrix A commonly denoted by det A or delta A or absolute or this delta A. The matrices which are not square do not have determinants. Determinants are quite, see, for 2 by 2. Wait. This is for 3 by 3. How to calculate that also it is given here. Same way we have calculated that. Minor and cofactors. See, for every element they have written here the minors. Along with that minor, when we associate the sign, they are called cofactors. That sign rule they have done here according to rule, but you don't do in exam like that. You remember that sign rule, minus plus minus plus minus plus minus plus minus. It will be better. So don't go away. The property of determinant guy will have to remember. Luckily, the application is not in your syllabus. Otherwise, this would have been very difficult. Luckily, only properties are there. So what they can ask you, theory-based questions they can ask you. And these properties you need to remember. And every property I have proved in the class video, if you remember. See, singular and non-singular matrices, any square matrix A is singular if delta is equal to 0. And the matrix is non-singular if delta is not equal to 0. These examples, guys, go by these examples. Adjoint matrix or adjugate of a matrix, then inverse. Okay, adjoint, adjugate, and inverse. And then Cramer's rule. Okay. We'll discuss about that now, guys. See. Now, adjoint or adjugate. Wait. Guys, it will start with the plus, not with the minus. This sign plus minus plus minus plus minus plus minus plus. Now adjoint or adjugate. See. Guys, here I have actually in class video I have taught you a lot of other things, but all those things cannot be discussed here in revision video. Otherwise, it will be very lengthy. So only some main points I am going to touch. Adjoint of a matrix. Adjoint or adjugate. And what is that? That is the matrix of cofactors. A matrix A is given to you. How will you find out the adjoint? A adjoint, symbolically written this way, will be calculated by what you know. This A element, this A matrix is given. So you are to write down the cofactor of each and every element of this matrix A. So in short, what I am writing? Cofactors of each and every element of the matrix A. So in short, I am writing cofactors of A. Clear for your understanding? Informal language, guys. Cofactors of A and then its transpose. That will be adjoint. Now, how to calculate inverse of a matrix? Wait. How to calculate inverse of equal to 0? Then that will be a singular matrix. And something by 0 is undefined, So A inverse will not exist if data is equal to 0. That means A inverse will exist only if it is a non-singular matrix. So anywhere if you are asked to calculate A inverse, all of first you should check whether it is singular or not. If it is singular matrix, then and there it will stop. Why? Since A is a singular matrix, its A inverse does not exist. And if it is non-singular matrix, then only you can go ahead to find out the A inverse. How? First you will calculate the adjoint like this, and then you will calculate the inverse of the matrix. Clear, guys? Now 3 by 3 it will be very lengthy, not 1 mark question. But if it is a 2 by 2 matrix, guys, I have taught you shortcut how to do very fast. You remember? To see that, you may go to class video, or else wait. Here I will take one example, and for 2 by 2 only, guys, because no need to discuss 3 by 3 for 1 mark. Suppose A is a matrix and the elements are A, B, C, D. Randomly I have taken A, B, C, D. So if you go to calculate A adjoint by rule, so see what you'll have to do. A adjoint, you are going to calculate. You know what's the rule? Write down here their cofactors and then the transpose of that. Here you are to write down cofactors. Cofactors means the sign rule for 2 by 2, you know, plus, minus, minus, plus. So what will happen? Plus, minus, minus, plus. Now, the cofactor of this means sign already I have written. So now I will write the minor. What is the minor of this A? Delete the row and the column in which this is line. So what is remaining? D. So it will come D. Now, for this B, delete the row and the column in which this is line. So what is remaining, guys? C. So here it will come C. Now for C, what will happen? For this C, delete the row and the column in which this C is lying. So what is we are getting? B. And now for this D, delete the row and the column in which this is lying. So what is remaining? A. So A will come here. Now if you do the transpose, you will get A adjoint. So A adjoint, if you do the transpose, the first row D and minus C should be written in first column, D and minus C. Then second row minus BA, write in second column, minus BA. This is your A adjoint. But guys, if you don't want to do the intermediate step, directly you can jump from here to here and directly you can write A adjoint. How, sir? Check yourself. No need of showing or giving you any clue. You can get yourself. Just look at this to understand. See what has happened to this A and D. See this corner. A and D, this diagonal you see A and D. And now you see in the resultant what has happened. They are exchanged now. In place of A, what has come? D. In place of D, what has come? A. That means for this diagonal, just exchange these two elements. Now see what has happened to these two. B and C. Sir, B and C elements are remaining on their places. Only their sign are changed. Same you do. That means for this diagonal, what you will do? You will not exchange them, but you will change their sign. Elements will remain on their places. Only their sign will be changed. So this way you can jump directly from question to answer, but you don't want to take risk. Because in exam, you know, any kind of confusion can arise in your mind. Then you write down this intermediate step also. Clear, guys? So, A inverse also you have seen. Now, Cramer's rule. Cramer's rule for what? Solving equations. Solving equations we can solve by matrix inversion method also and by Cramer's rule also. For example, 2x plus 3y is equal to 5 and 3x minus 2y is equal to 1. These are the two equations I have taken and you have to solve it by matrix inversion method. Already we know the answer is 1 1. Sir, how do you know? Because already I have set these points in my mind and then created these two questions. You check by putting, you'll satisfy. So by matrix inversion method, what you have to do, guys? You will make a matrix of the coefficients, that is 2, 3, 3, minus 2. Then the matrix of variable, that is xy, and then value matrix, that is 5 and 1. And then you know x can be given as A inverse into K. Not going to discuss, guys, that point, because if they will ask this question, solve this by matrix inversion method, who will go to solve? That rule you remember? No, x is equal to A inverse into K. But we will not go by that. A rule they can ask you, so remember this formula. If they will ask what are the values of x and y, simply by substituting method we will get x and y. Why will you go to do this way? But this rule, formula you have to remember because they can ask you the formula. Same thing, what Kramer taught, that if you want to solve these two, then all of first take a determinant, name it delta x. How? Determinant you have to take with their quotients 2, 3, 3 minus 2. 2, 3, 3 minus 2. 2, 3, 3 minus 2. Sorry guys, this is delta, main determinant. Now, next again delta x. And how will you obtain this? First column will be replaced by the value. By the value means these are the values 5 and 1. That means the first column will be 5, 1. Second column will remain same 3 minus 2. Again you will calculate delta y. How? This time first column will remain same. Second column will be replaced by that value. That is 5 and 1. Now calculate their values. So 2 by 2 easily you can calculate. Left into left first. So 2 into minus 2 minus 4. Give a minus sign. Now 3 into 3 9. So it came minus 13. Now your delta x is equal to how much? Left first guys. 5 into minus 2 minus 10 minus 3 into 1. That is this. Minus 13. And now delta y. And that is equal to 2 into 2. 2 minus 5 3 are 15. That is equal to minus 13. Our x value will be calculated by this delta x by delta, and y value we will get by delta y by delta. So that is equal to minus 13 by minus 13, that is equal to 1. Here also it is minus 13 by minus 13 is equal to 1. We are getting the value of x and y. So, but they can ask you the formula, not the full solution. Okay, guys. So all these things in matrix over. Now, if you want to see some questions, see the questions. Wait. In a matrix, if a matrix has 16 elements, what are the possible orders it can have? It's loading is wait. Yeah. Possible orders. Guys, 2 by 8 means how many? 2 by 8 matrix means how many elements? 2 is 16. 8 by 1 means how many elements? 8 1 is 8. So this will not be the answer because question told 16 elements. If you see this 2 8 is 16, fine. 8 2 is 16, fine. But 4 1 is 4 elements and question told 16 elements. If you come to option B, 2 8 is 16, 8 2 is 16, 4 4 is 16, 16 is 16, 16. Yes. Here, in everywhere, in every order, 16 elements will be there. Transpose of a rectangular matrix is a transpose of a row matrix is a row matrix, and we are multiplied to get AB if the rule they are asking, guys. Rule you know, number of columns equal to number of rows, data is equal to 0 is called singular matrix, you know. Yeah, guys, these questions you only answer, you know. See here, question number 9. What is small a if capital A is equal to 2, 3? What is this? 4 and A. 4 and A is a singular matrix. Singular matrix means what? Its determinant will be equal to 0. So left multiplication first, that is 2a minus 12 is equal to 0. A will be equal to solve. 10 guys. Left minus right. I square given minus 1. That will be your determinant. A plus B. Guys, these are very easy questions. Unnecessarily, if I go to solve and show, that will be a wastage of time only. All questions easy early, guys. Look here. This type of question I have discussed. Guys, you remember one more thing. If two matrices are equal, then it is only possible if their corresponding elements are equal. Two matrices equal only when they are of same order, as well as their corresponding elements must be equal. Corresponding elements must be equal means, suppose if I give AB25 is equal to 3BP5, 2 by 2 both the sides, but their corresponding elements must be equal. That means what? A must be equal to 3. This B is equal to B, fine. This 2 must be equal to P. Then this 5 is equal to 5. Their corresponding elements must be same. All questions are involving multiplication only. Okay. Guys, you can do these questions. No. See, this type of questions they're asking. X plus y is equal to -1, y plus z is equal to 1, z plus x is equal to 0. You don't need to solve, guys. See, a dash dash. Do you need to solve? No, directly you will write. A transpose of transpose is equal to A. Ulta of ulta is equal to Sida. Easy only. You will solve yourself, guys. I don't think there will be any doubt. I have not seen any question where there can be any doubt. If doubt will come, that means that will happen because of your calculation mistake only. So if any question, your doubt, you may ask